Good morning, everybody. Last time we have to explain our third chapter and first unit. Today, I will explain your third chapter and second PPT. So, in this chapter, photoelectricity, X-rays, and laser. Last time we have to explain this chapter according to MHBT for 11 marks. So, today I will explain Einstein photoelectric equation. According to quantum theory, the radiation considered as a short wavelength of particles is called photon. Each photon carries energy E equal to h nu. Already you have to know E is the energy of photons, h is the Planck constant or Planck hypothesis, and nu is the frequency of light. So this E equal to h nu, this phenomena, this statement introduced by Einstein. Again, in 1905, equation to explain this effect E equal to mc square, E equal to h nu according to Planck hypothesis, but this equation modified by Einstein, E equal to mc square. Here is m is the mass of electrons, c be the velocity of light, and E be the energy of photon. Kinetic energy of photoelectrons equal to energy obtained from the photon minus the energy used to escape the metallic surface. W0 is the work function. So E equal to h nu. Einstein explained this is the Einstein photoelectric effect diagram. So this is the plate, that is metal plate. When radiation of light or light falls off the metal plate to emit the electrons, and this emitting electrons is called photoelectric effects. According to this equation, radiation is considered a shower of particles called photons. Already you have to know. Each photon carries the energy equal to h nu. These photons travels with the speed of light, that is speed of light is 3 into 10 to the power 8 meter per second. The light is incident on the metal surface. During the collision, energy of photon is observed by the metal atom. Thus now energy of an atom is h nu. So h is the Planck constant or Planck hypothesis, and nu is the frequency of light. This is the circuit diagram. Here is positive. This is the long terminal also known as positive, and short terminal, this is negative. This is the surface, metal surface, and this ray of light or light falls on the metal surface to emit the electrons, and that emitting electrons is called photoelectrons, keeping your mind. Then equation 1, that is nu equal to frequency of light or radiation, h is the Planck constant, and nu 0 is the threshold frequency. W0 equal to work function, m equal to mass of electrons. Using this value of nu and kinetic energy in equation 1, we have h nu 0 minus W0 equal to 0. So h nu 0 equal to W0. Here is W0 is the work function, h is the Planck constant, and nu 0 be the threshold frequency. Keep in your mind, nu 0 is threshold frequency. Using in equation 1, we have kinetic energy equal to h nu minus h nu 0. Kinetic energy equal to h nu minus h nu 0. This equation we can modify in this way. Take common on both sides h, so kinetic energy equal to h in bracket nu minus nu 0, and this is our equation of photoelectric equation by Einstein. So kinetic energy, already we have to know kinetic energy equal to half mv square. Here is the mass of electrons and v is the velocity of light. So half mv square equal to h in bracket nu minus nu 0. So both equation is Einstein photoelectric equation, keeping your mind. Find the above equation, kinetic energy is 0, emission just begin, nu equal to nu 0. Kinetic energy is 0. You have to consider if kinetic energy is 0, nu equal to nu 0. It means that frequency of light is equal to the threshold frequency of light. Then kinetic energy is negative, no emission takes place, so nu less than nu 0. Then kinetic energy is positive, emission takes place, nu greater than nu 0. Then photoelectric cell. This is the diagram of photoelectric cell. This is A anode and this is C cathode. This is the battery connected to the circuit and micrometer or ammeter also connected to the circuit. When light falls on the metal plate to emit the electrons, already we have to know. So this phenomena we have to use in the photoelectric cell. So in the photoelectric cell, we have to use the circuit diagram, keeping your mind. So in this case, photoelectric cell, light energy is converted into electrical energy, keeping your mind. In photoelectric cell, light energy is converted into electrical energy. Photoelectric cell consists of cathode C and anode A. The semi-cylindrical cathode coated with the photosensitive material from the inner side. The anode is a rod of platinum kept along the axis of cathode. The cathode is connected to the negative terminal, keeping your mind. This cathode is connected to the negative terminal of the battery and anode A is connected to the positive terminal of the battery. The cathode is connected to the negative terminal of the battery and anode is connected to the positive terminal of the battery. Anode and cathode both are connected to this circuit. When the light allowed to falls on the cathode, it emits electrons, already you have to know. When the light falls on the metal plate to emit the electrons, and that electrons is called photoelectrons. The photoelectric current flows through the circuit and through the milliammeter. So this is the milliammeter we have to use in the circuit. The photoelectric current flows through the circuit and milliammeter shows the deflection, and to get the deflection in the milliammeter. So in the photoelectric cell, there are three types of photoelectric cell, keeping your mind. Number one, photoemissive cell, photoconductive cell and photovoltaic cell. Photoemissive cell, photoconductive cell and photovoltaic cell. So this is the three types of photoelectric cell. Now application of photoelectric cell. This photoelectric cell is used when the light falls on the photocell. It becomes on when the intensity of light increases, then photoelectric current increases. Second application, photoelectric cell is used in the lux meter to measure the intensity of light. Third, photoelectric cell is used in the automatic control of the tropic signal. Photoelectric cell is used to switch on and off automatically the street lights. The photoelectric cell is used recording and reproduction of the sound during shooting of a film. It is also used in the television set, fire alarm. Photoelectric cell is used burglar alarm. Photoelectric cell is used in the exposure meter as well as lux meter to measure the intensity of light. So student, out of this application, one or two application must be asked in your job examination, keeping your mind. So student, today I stop here. Thank you very much.